developers how to do it. You know what a universal app is? It runs on Windows, which means it runs on laptops, on desktop PCs, and on tablets, and it runs on Windows Phone 8.1. And Microsoft said and built that they will soon run on other devices like Xboxes. So the future, I believe, on the Microsoft stack is WinRT. Because if we're going to be building apps for various Windows devices, phones and tablets and stuff, it's the WinRT API that we're writing to. So there's a small segment of the WinRT team in Redmond, Washington, that was tasked with building an API that wraps and abstracts NFC. I think they've done a fantastic job. Because when you build an NFC API, one of the things you want to do is abstract the underlying details. You don't want developers to have to write driver-level code to negotiate connections when two devices come in proximity and stuff like that. I think that this team struck a very good balance between level of abstraction, making the code easy to write, and not making it so abstract that we couldn't get this API to do the things we want it to do. So, there are two primary classes in WinRT. Remember, you can call these from a Windows Store app or from a Windows Phone app today. Two primary classes that expose NFC capabilities to you. One of those classes is called proximity device. It literally represents an NFC-equipped device. That is a device that has one or more NFC chips in it. That's the first class we're going to look at. We're going to see how you can find out if your device is equipped with NFC, when another NFC-equipped device enters your proximity so you can exchange messages with it, etc. Another class that they built into the Windows.networking.proximity namespace in WinRT is one named PeerFinder, which not only plays a role in building NFC apps, but also provides some interesting Bluetooth APIs to us as well. We're going to use PeerFinder to enable haptic connect, so that when two NFC-equipped devices come together, they can recognize that, negotiate a connection, and continue to communicate using higher bandwidth network protocols. So that's kind of the high-level picture of where we're going. The rest is details. So we're going to talk about this. First, if you're going to build a WinRT app that uses NFC, you must indicate as much in the application manifest. If you haven't built a Windows Store app before, when you build a Windows Store app, maybe that's where the static is coming from. One of the things you do in Visual Studio, is you build a manifest. It's actually a file that is packaged in the application package, and it has a lot of information about that application. This applies to both Windows Store apps and Windows Phone apps. In both Windows Store apps and Windows Phone apps, you must go into the manifest in Visual Studio, and you must check a box indicating that this app uses NFC. This way, before a user downloads this from the Windows Store, they know that it's going to require NFC networking and can elect not to download it if they want. If you don't check the requisite box indicating that this is an NFC app in the application manifest, the code will compile and run just fine in the test environment. But when you try to actually run it on a device, it will just throw an exception every time you call an NFC API. So don't forget to check these boxes in the manifest before you use this. So let's start with the proximity device class. Again, in WinRT, it represents devices that are equipped with NFC. It provides a simple API that lets you get information about the device and will let you know when other devices that are also equipped with NFC enter your proximity. So here's one way to use this class. Before you use NFC APIs on a device, whether it's a tablet or phone or whatever, you need to make sure that device supports NFC. Now, this tablet right here is not a Microsoft Surface tablet. Unfortunately, none of Microsoft's Surface line has NFC chips in it. This is a Samsung tablet that they introduced Windows 8 on, I think 3 years ago at Build. One reason I still use this tablet a lot is because it has very nice NFC support in it. This Windows Phone is a Lumia 920. It has an NFC chip in it. So does the Lumia 1020 and the 1520. Some of the lower-end Windows phones do not have NFC chips. So before I do anything with NFC on a device, whether it's a phone or a tablet, I better make sure that there's NFC support on this device. How do you do that? Very simple. You call proximity device.getDefault. Notice it's a static method of the proximity device class. If that returns null, that tells you that the device this code is executing on does not have an NFC chip. If it does not return null, then it returns a reference to a proximity device instance from which you can get more information about that device. Specifically, you can get this. Number one, you can get a device ID. This is actually the ID encoded in the NFC chip on that device. You can also get bits per second. It turns out every NFC chip has a maximum transfer rate. If you want to know what that is, in order to make an intelligent choice about whether to try to transmit a lot of data or little data, you can get a figure in bits per second here, indicating how much data this device can transfer. There's also a property you can read called max message bytes. Every NFC chip has a maximum number of bytes that it will transfer in one message. It varies from chip to chip. It's usually something fairly large, like 2K to 20K. But if you intend to send long messages to other NFC-equipped devices, you might want to check this value first to make sure that you don't have to break it up into multiple messages. Now that's all fine and good. It lets you find out whether your device is NFC-equipped, and if it is, it lets you get some information about it. But look what else you can do. Remember that NFC is called NFC, near field communication, because it only works when devices are in close proximity to each other. They don't actually have to be touching. They usually have to be within 2 to 3 centimeters of each other. So if you're an NFC-equipped device, you may want to know when another NFC-equipped device enters your proximity. That's why the proximity device class in WinRT defines a pair of events named device arrived and device departed. Once you have a proximity device reference, you can wire cameras for those events. Sure enough, if I take another Lumia 920 or an NFC-equipped tablet like this and I bring it up to my phone, bingo, that device arrived event will fire. Then, if I draw them apart when they get about an inch or so apart, bing, that device departed event will fire. Now, why is this important? Because I'm going to show you APIs for sending messages to other NFC-equipped devices. There are 2 basic ways to go about that. One is you can broadcast that message so that it's just going out there. And if there's no one listening, that's okay. But if another device comes up to you, it can receive the message. Or you can wait until another device enters your proximity to begin broadcasting the message on a mobile device. The latter is more efficient with battery power. That's why they gave us these events right here. So we're going to see these events used here in a few moments. The whole point of NFC is to be able to send messages of various links to other NFC devices so that we can shoot pictures between devices. We can do distributed games between devices and things like that. One of the methods that the proximity device class gives you, where's that feedback coming from? That's something I know. Oh, that speaker. Oh, is it coming from that speaker right there? I think someone's going to look at it there. We can just turn that off if we need to. This is a small microphone. I apologize. I think the legs are on, so it's catching or something. Maybe. Is that better? Okay. That going around a little bit. Perfect. Okay, good. So, with the proximity device class, we have an event-based API for learning when devices enter and leave your proximity. We also have a method, which is one of 3 methods you can call on proximity device for sending a message to another NFC device. I'm going to show you what these APIs look like, what the 3 methods are. But rather than dump them on you all at once, we're going to talk about each one in context, and then I'm going to show you a demo or 2. The first proximity device method I want to introduce to you for sending data to other NFC devices is one named publish message. Now, they call it publish message because they're thinking of a publish-subscribe type pattern. If I want to send a message to another NFC device, one way to do that in WinRT is to call this publish message method. The interesting thing is, it publishes a message until I tell it to stop publishing. In other words, I call publish message. If another device comes up within my proximity, that device can, if it wants, receive the message. but it doesn't stop when that device pulls away. Since I call publish message, it won't stop until I call another API to stop publishing. So as long as devices enter and leave my proximity, they will receive those messages. Now, it turns out that publish message is primarily designed for communication between Windows devices. So while NFC itself and the NFC data exchange format can be used between, say, Windows devices and Android devices, this method won't let you do it. Microsoft designed this to make it easy to send data between different Windows devices. So here's what I can do. I can call publish message. If I want, I can just do this when my app starts up or when the user presses a button. Or if I prefer, I can only do this when I get a proximity device arrived message. When I call it, the first parameter I pass in is a string, which is the message name or message type. This has to begin with Windows dot. What comes after the dot, you can make up anything you want. What's key here is that the sender and receiver have to agree on this message type, and it must begin with Windows dot. In the second parameter, you can pass a string. If another device enters your proximity and registers to receive this message, it will receive that string. Now, when you call it, as I do there, you don't know if another device has actually received that message, but you can use an overloaded form of publish message, which accepts a callback delegate in the third parameter, and now each time a device arrives in your proximity and receives the message, you will get a callback telling you the message has been transmitted, and that in and of itself doesn't stop publishing the message, but you could, if you wanted, elect to stop publishing the message the moment you've seen that one device accepted it. In fact, right here is the method that proximity device gives you for stopping publish message, for reversing it. It is called, not surprisingly, stop publishing message. Remember, you want to stop publishing the message as early as possible, because when you are publishing a message with NFC, that NFC chip is powered up. It's got a little antenna that's actually drawing current, and you are draining the battery power on the phone. So you never want to have this thing out there just blowing data out there when you don't need to be. So I'll show you an example of what we do in the UIs to make sure that we only send that data when we need to. Now, publish message allows me to transmit other data. In fact, stream data to Windows Phone. It's a fairly restricted API. We can't send binary data with it, although we can stream encoded, which I'm going to do in my first demo. But it's not for sending binary data, it's for transmitting string data. Its counterpart is subscribe for message. If I'm an NFC device and I want to receive data sent by other devices using publish message, then I call subscribe for message. Now, when I do that, I can specify what type of message I want to subscribe to. What I want to do here, if I want two devices to communicate, is use the same string, the same message type here, that the device is publishing the message via publish messages. Again, the one restriction is that it has to begin with Windows dot. When I call subscribe for message, I provide a delegate in the second parameter that wraps a callback that will be called if my device, the one hosting this code, enters the proximity of another NFC device that is publishing that message, and in it, from data as string, and that property of the proximity message object transmitted in the parameter list, I receive the string that was sent to me from the other device using publish message. So it's a fairly simple API. They designed it to be just as simple as it possibly could be. So let's try something here. Let's see if it actually works, okay? Because for all you know, I could be making up everything I tell you today, right? If I don't show you code, if I don't do demos, you should be skeptical of everything I say. Now, I would never do that. I would never make it up. But I'm going to prove to you that this actually works. So what I'm going to do here is fire up this Samsung tablet here. We'll give it just a moment. In fact, I'll have to log in here. Since it is a Windows device, it's actually running Windows 8.1. I originally did this demo on this tablet running Windows 8. It works just as well there. But let's get logged in here to 8.1. So, I'm going to get that running. And the other device I'm going to use in this demo is my Lumia 920. So here's what I'm going to do. first off, I'm going to start a little app on here. Let's get it up here. It's called Content Receipt Demo. That URL I gave you at the beginning of the session contains a zip file with this code and other code as well. And here's what this is. How many of you have ever seen or heard of or maybe written an implication of John Conway's Game of Life? Yeah? Entire PhD dissertations have been built around it. You draw a little grid of cells on there, and then you can pull up this bar down here called the start, and you evolve the cells from one generation to the next using some genetic algorithms that Conway laid down. So there is an implementation of that running on a Windows tablet. Now, I happen to have an implementation of that, a separate version of it that I built for Windows Phone. So let's get that up here. You can see this here. You see that basically the same grid of cells on the smaller screen that you see on that tablet over there. And I'm going to draw something in here, maybe something that looks interesting, or maybe it's not that interesting, I don't know. First, before I do anything else, let me clear this one. I'll tap that so that empties out. So I've drawn something that I think is interesting here. What I'm going to do here is tap a little button. And why it's grayed out, which tells me it can't be shared right now. Let me make sure. I just installed, let me make sure I have NFC enabled. That was an airplane mode. I'm now out of airplane mode. And we're going to run this app again. And it's still not lighting up the NFC button, so I'm going to go into settings and make sure that that's turned back on. You can turn NFC on and off on these Windows phones. Let's see, I definitely have airplane mode off. We've got Bluetooth on. NFC turned off. That's interesting. When I brought it out of airplane mode, it must not have come out. So in Windows Phone settings, this screen is new in Windows Phone 8.1. I just enabled NFC. Okay. Now let's see here. Let's go back and run this app. And let's see. That's the wrong one. Let's see here. And there we are. Now, I'm going to draw a little grid of cells in here, okay? And let's say I come up with something I think is really interesting here. Down in the app bar at the bottom of the screen, I have a share button. When I tap that share button, I'm going to call publish message on this phone to broadcast to other NFC devices data that represents this grid of cells. On this application over here, where I show that same grid of cells, I have called subscribe to a message. It's listening for another device to enter its proximity, publishing that message. So I'm going to tap the share button right here. And you have to get this just right because the NFC chips have to come pretty close to each other, but when I get them just right, Samsung tablet, the chip is right behind here. When I get them just right, there we go. Did you see what appeared there? And if you look at those two cells, grids of cells are identical, right? So what did I do here? From this device, when the user tapped the share button, I called publish message to broadcast the little message depicting the cell grid here. And this app over here, when it started up, I called subscribe to message, so it's listening for those messages. Now remember, with the publish message and subscribe to message, you can only transmit strings. But it was easy enough to transmit a string of ones and zeros representing that cell. I just consumed that string on this side and duplicated that cell grid. So there's an example where I didn't need a higher bandwidth connection. The amount of data I was transferring, which is only about 200 bytes or so, was so small, it was perfectly fine to transmit all the data while the devices were in contact. Could I transmit an image that way? A 3 or 4 or 5 or 6 megabyte JPEG image? I could. But the user's probably going to get pretty tired of holding those two devices together. So we'll have to find better ways to do that. But for short amounts of data like this, direct NFC communication between devices is absolutely fine. Now, let me show you how easy it was to do this. I'm going to go over to Visual Studio and open a project containing that code again. This URL right here, if you got it a little bit late, you can go to this URL at your convenience. You can download a zip file containing these samples that I'm showing you. So let's go open this project up. And to do that, I'll go over to my samples folder, and somewhere here, under put most of these, yes, under this NFC folder. This one was called NFC Content Sharing Demo. When you open it up, it has both a Windows 8 project in it and a Windows Phone 8 project in it. So do we want to do that? Okay, yeah, we may do that, or may not. So I'm going to close that out for now. Here is the Span Solution Explorer just a bit. Here's the app that was running on the tablet. And the key is what I do in mainpage.xaml.cs. When this app starts up, I check to see, right down here, if this is an NFC-equipped device. So I call proximity-device.get default, as I showed you in the slides. If the return is non-null, that means it's a proximity device object reference. Then I call subscribe for message, and I'm saying, hey, if another device enters my proximity, publishing a message whose type is window.live, tell me about it. Call this callback right here. And in that callback, all I really do is I take that data as string property of the proximity message that comes to the parameter list. That is that string of ones and zeros that represents the cell grid, and I decompose the string and replicate the cell grid here on the receiving side. Now, if you look over the Windows Phone side, rather than doing the receiving, it's doing the transmitting. So let's look at the handler that executes when I tap that share button. First, when this application started up, I did check to see if it was NFC equipped and if NFC was enabled. And if not, then I disabled the share button in the app bar. That's how I knew something was wrong, that NFC was turned off or something when I started the app up and saw the button disabled. So here is the handler that executes when that button is tapped. It's called on share. I check again to make sure that I am a proximity or NFC equipped device. If the answer is yes, then here I'm building that string of ones and zeros representing the cell grid that the user drew on the phone. And here's the key. I call publish message to publish an NFC message called windows.live to anyone that's interested. Now, you can see it's important here that the sender and receiver agreed on this message name. Now, notice that I use the form of this method that accepts a callback in the third parameter. In order to conserve battery power, once my device was tapped to another that received the message, I wanted to stop publishing the message. So I register for this callback, and when I'm told by the operating system that the message has been transmitted to another device, then I stop publishing the message. So if I then wanted to share that grid with another device, I would have to tap the share button again. And I did that primarily to save battery power. So that is one aspect of WinRT's NFC API. Works equally well on Windows and on Windows Phone. And it allows us using this publish message and subscribe for message method there to very easily transmit string messages. The shorter the better, although there's no theoretical limit on the size of the string, the shorter the better. String messages from one device to another. Okay? Do you like what you saw there? Yes. Okay? Because it's going to get better. That's just a start with NFC. Okay? Yes, sir. Question?
Can you connect more than two devices?
So it is one-to-one. It's one-to-one. There are some facilities for outside of NFC connecting multiple devices, like using multiplexing and UDP. But with NFC, it's always a one-to-one connection. It's a great question. Now,
yeah, before we proceed further, I'm just trying to understand what's the practical use case for NFC communication, because there are so many protocols, Bluetooth, RFIDs, and all those things.
Yeah.
So really, where is that NFC going on?
So here's the real importance of NFC when it comes to that. The thing with Bluetooth is you either have to pair the devices together so that they can talk to each other, or you have to have one of those devices advertise itself so that another device can find it. Either way, there's some setup, there's some preparation required. My wife, for example, with her Windows Phone, she's paired it with the speaker in her car so that she can talk over the speaker. She had to go set that up. With NFC, no setup required, no pairing. As long as I can touch the two devices together, boom. When you go into an AT&T store in the United States, you can buy, in most of the stores, Bluetooth speakers, so you can wirelessly play music over those speakers from your phone. Guess how they get the Bluetooth connection? Through NFC. Do you want to have to pair those together, or do you want to just have them together one time so they know about each other? So that's the role NFC is playing. It makes the devices really easy to discover. And while they're close together, it's perfect for sending short messages. Now, in that example there was no Bluetooth, no Wi-Fi. Since while they were in contact, I shot a 200-byte stream from one device to another. So it's all about convenience for the user, ease of use. Now, here's where it gets better, folks. Let's go back to PowerPoint here for just a moment. The proximity device class represents NFC-equipped devices, has an event-based API that lets you know when the device enters or leaves your proximity, and it has those methods named publish message and subscribe per message. It also has a couple of other methods, which I'll say more about right at the very end. But I want to spend a little bit of time on the other primary NFC class in WinRT, which is the peer finder class. Now, if what I want to do is establish a connection between two devices and transmit larger amounts of data like a photo, then the NFC itself isn't going to be sufficient. I want to use NFC to let the devices find each other, but then establish a higher bandwidth connection, Bluetooth or Wi-Fi, so the devices can be pulled away and still communicate. That's what this class in WinRT lets you do. It takes something that's actually very complex under the hood at the driver level, and it makes it incredibly easy to do up at the C# level. So Peer Finder does this. First off, before you use it, not only does your device need to be NFC equipped, it needs to have a driver installed, basically, to enable this so-called Haptic Connect scenario. So before you use what I'm about to show you, you always do this. You check to see if your device supports NFC Haptic Connect. If the answer is yes, then you proceed from there. If you determine that it does support it, then you go further. First, you wire up an event handler for Peer Finder's static trigger connection state changed event. Then you call a static method named peerfinder.start. What happens down at the chip level then is interesting. This device begins broadcasting, basically listening for other NFC-equipped devices that also support trigger connections to enter their vicinity. Now, if you hold another device up to this one, this trigger connection state change event will fire. Not just once, but typically 5 or even 6 times as the two devices negotiate over NFC, a Bluetooth or Wi-Fi connection. The key is that when the connection has been negotiated, then a trigger connection state event will fire. It will have a state property, the event args, equal to trigger connection state dot completed. That tells you that these two devices are not talking to each other. And guess what? Through the event args, through the socket property, you get a reference to a stream socket object. A stream socket is the class that represents TCP sockets in WinRT. You see what's happening here? You've used a simple API that lets two NFC-equipped devices be tapped together. Down at the driver level, we've negotiated a connection, Bluetooth or Wi-Fi or Wi-Fi direct, and now you can pull the devices apart. This is how Windows phones transmit pictures, share pictures between devices. This is how Android phones do it as well, using NFC Tap to Connect. Now, I'm going to show you an example of this at work to show you how easy the API is in just a moment. Let me mention this. By default in WinRT, whether this is an app running on a phone or running on a tablet or even a laptop or a desktop that has an NFC chip in it, by default, when those two are tapped together, Windows will try every type of connection available. It will try to establish a Bluetooth connection and a Wi-Fi connection and a Wi-Fi direct connection. Both devices support that. And the one that you'll get will be the one that comes back the quickest. That's usually the Bluetooth connection. If you care about what type of connection, what type of transport is going to be used, then before you call peerfinder.start, you can set one or more of these properties of the peerfinder class that false. For example, If you need a very high bandwidth connection that even Bluetooth isn't sufficient for, before calling PeerFinder.start, I can set allow Bluetooth to false. Now Windows won't even try to establish a Bluetooth connection between those devices. The default is it will try all of those and give you the first one that comes back. Here's something else that's interesting, and this is not documented very well, but I wanted to show you this, and then I want to demo it for you in my next demo. In most cases, when we use this API to tap devices, connect them, and establish a higher bandwidth connection, we're thinking about two devices that are similar, a Windows Phone and another Windows Phone. But when the WinRT team designed this API, they specifically built in, but to be honest, did not document very well, a mechanism for connecting together devices that are not similar. For connecting a device running the Windows operating system, for example, or a device running the Windows Phone operating system, or for connecting a Windows device to, get this, an Android device. It's called alternate app identities, and here's how it works. To use this tap to connect API, which I'm going to demo for you in a moment, by default, two devices running the Windows Phone operating system can just connect, or two devices running the Windows operating system can just connect. But if you want to connect a Windows device to a Windows Phone device, you have to do this. In the Windows Phone app, you have to specify something called an alternate app identity. In the PeerFinder class, you have to say, I want to connect to an app on a different platform, something other than Windows Phone. You specify with the string Windows if this is a Windows app you want to connect to, and here you specify the ID of the Windows Store app that you want to connect to. This is something that comes out of the manifest. Conversely, if you're building a device that's going to run on building an app that's going to run on a Windows device like a tablet that wants to use tap to connect to establish connections with Windows Phone devices, then in the Windows code you have to do this. You have to go into PeerFinder and say, hey, I'm going to tap to connect. And I may be connecting with a non-Windows device. I may be connecting with the device that's running Windows Phone. And this is the ID of the app that I want to be connected to if it enters my proximity. Now, Microsoft has not documented this, but you can use this to connect Windows devices and Windows Phone devices to Android devices as well. Now, let's do this. Let's look at a demo. To do that, I'm going to go back to my tablet here. There we are. Looks like I'm going to have it sign in again, which is not a problem. And this time I'm going to run a different app on this one. This one, too, is part of the zip file whose URL I gave you. It's called Find It, and this one is called Windows Scribble. Now, I need a volunteer to help me with this demo. If you wouldn't mind, why don't you come right up here? And in fact, better yet, stand on that middle step over there because I'm going to get some distance between us. So I want you to hold this up, and I'll be over there with you in a moment. Now that app running on Windows 8.1 right now has a little screen that says Tap to Connect. I'm going to run a similar app that I wrote for the Windows Phone. The source code is in there too. And similarly, when it starts up, I see a message that says Tap to Connect. So I'm going to walk up here, and I'm going to have to do this just right again. Knowing where the NFC chip is on this tablet, I'm going to have to get it really close. Okay, and it'll play a little noise when I get it right. Let's try it this way. Sometimes you just have to. This one. Oh, guess what? I hit the wrong button. Cortana's showing here. So I don't want Cortana. I love you, but that's not what I want right now. So once more, I'm back to the app that says Tap to Connect. So let's try it again. I'll try not to hit the button to get Cortana up there. When I get it just right, we're going to see that message change there. Make sure Cortana's not on there. Now it's actually on this side, but you know what? Try that. Sometimes it's kind of stubborn. When you hold it upside down here. I'm going to try this. Let me try holding it here as not your fault. The chips, it's not hard on the phone. The chip's about right here on the Windows Phone, but you have to know where it is on the tablet. And because you can really scratch the back of your tablet like this will do. So here's what we're going to do. So if you will hold the phone there, we're going to restart it on both of these. Sometimes they can be a little bit finicky, but I know this works, so we're going to try it again. So we're going to run this.
I have a quick question.
Yeah.
Is it necessary for the app to be live and active on both the devices to connect, or is it possible to have it running in the background and...
The app only has to be installed on the device. It doesn't have to be running. Oh, well, no, I take that back. In this case, the way I'm doing it, the app has to be running. There is a way to connect via NFC when an app is not running as well. You know what's interesting right here? I just got a message on here saying tap to connect is not supported, which cannot be true, because I've done this demo 1 million times on this tablet. So it must know it's an India. It's probably
That's not right.
So at this point, I'm going to reboot the machine because this is absolutely not right. At least that gives us something of an idea of maybe what was going on. So we'll just hold on to that phone there for just a second. We'll get her rebooted. And hey, when nothing else works, good Control-Alt-Delete rarely ever fails, right? Yeah, interesting. I'm getting that message. Okay, so we start this thing again. And we know NFC is enabled on this tablet because we transmitted an NFC message to it a few moments ago, so there's no need to go into settings and check that. But a good reboot right here. We won't even tell Windows that we're on the other side of the world. Okay, that's good. We didn't get a message saying it's not supported. We get that message saying tap to connect. Now I'm going to try this again. And I still need you here because we're going to have to, once we get to connect, kind of walk apart here. So let's try this one. Now, wish me luck. We're going to try to get them connected. Hold them just right. Hold it. Got to hold my mouse just right too.
You should just try Bluetooth.
So I am going to, once they connect, I'm going to use Bluetooth. Did you hear that? Oh, wait a minute. Hold it away too quickly. You hear that? And in a moment, it's going to tell me I can pull it apart. Okay. Yes. Now, if you will hold that. So, okay. Now, they are connected. It was a little bit temperamental getting there. But basically, I registered a handler for that trigger connection state event, trigger connection state changed event, and both devices know they're connected. Now, what I'm going to do here is I'm going to send you a message, okay? So I'm going to draw on here, I'm going to write the word hi. And then look what appears over there. So what happened here is we negotiated a Bluetooth connection over NFC. NFC is only good within when the devices are within an inch or so of each other, but clearly they're a lot further apart. Bluetooth is good for much longer, so is Wi-Fi. Now, you can write me a message too. So just scribble whatever you want to. Nothing dirty now. And he's going to write a secret message to me that's going to appear on this phone right here. And very nice. So everyone might be able to do whatever he had that duty. But isn't that cool? What do? We used NFC. No pairing, as we'd have to do with Bluetooth. We just walked up, tapped the two things together. Now, never mind that it took me about 2 minutes and one reboot just to get them really connected. But once we have connected them, they can just talk. Because all I'm doing is sockets networking. I've got a socket on both ends. I'm shooting data back and forth so that what's drawn on one device can be replicated on the other. It's a two-way socket connection. Thank you very much. Good job.
Another question.
Yeah.
So if you had another device coming in proximity now with one of these devices while this Bluetooth connection was on,
Yeah.
what would happen then?
Yeah. So if I had that connection, I could establish another connection with another device.
And would that be all three talking together, or?
No. I would have three devices, but like A would have a connection to B, B would have a connection to C. So B could talk to A and C, but the three of them could not talk to each other. Yeah. So in terms of like doing something like we might do with UDP multiplexing, that's not there. But yes, I can have multiple connections, multiple Bluetooth connections, or multiple Wi-Fi or Wi-Fi direct connections to other devices. And I can use NFC to establish those connections. But as far as actually having all three of them talk, no. That's coming in the future. It's not there just yet. Let me show you how easy it was.
One more question.
Yeah.
What is the order of this negotiation? So we have got three options available: Wi-Fi direct,
Yep.
Bluetooth, and Wi-Fi. So how does it choose that what's the preferred method? Or say requirement?
Yeah, so as far as Windows goes, if you look at the source code for that part of Windows, Windows doesn't care. Windows, when you call start, peerfinder.start, Windows tries to establish all three of those connections at once. And when the first one comes back, it takes it. So Windows does not define what the default is. It will say whatever is the easiest to establish. That's usually Bluetooth. The reason you might not want to use Bluetooth is because of the bandwidth. You can transfer more data faster over Wi-Fi to Wi-Fi direct than you can with Bluetooth. But clearly, for something like that distributed drawing application, Bluetooth was plenty sufficient for that. Yeah. So let me show you what the code looked like here real quick. It was easy to do that. I did have to use this alternate app identities infrastructure so that I could connect a tablet running Windows to a phone running Windows Phone. But it really wasn't hard to do. So let me open up another project here. This is also part of that zip file you can download. This one is called NFC Scribble Demo. And like the previous solution, it has two projects inside it, one Windows 8 project, another Windows Phone project. And once more, these are single-page apps, so the magic happens in mainpage.xaml.cs. In fact, the code is basically identical in the two of them. So it doesn't matter which one we look at. Let's just look at, we'll look at the phone version right here. So, when this thing starts up, I make sure here that we do support NFC Tap to Connect using code like I showed you in this slide. Obviously, if this phone doesn't have an NFC chip or if it doesn't have driver level support for Tap to Connect, it's fruitless to even try it. If I find that it does, I register a handler for the triggered connection state change events as I showed you in the slides and called peerfinder.start to start advertising for and listening for the other devices that want to connect to me. Because this is a Windows Phone app we're looking at, and I specifically want to be able to connect not only to another app running on a Windows Phone, but a similar app running on the Windows device. I add this entry to peerfinder's alternate identities dictionary, literally saying I want to be able to connect not only to an app like this one on the Windows Phone, but any app with this ID that's running on the Windows operating system. Over on the Windows side, you'll see that when I added that in there, identified Windows Phone in the alternate app identity. Now, going back over here, here's my triggered connection state change event handler. Remember, it's typically called several times as a connection is established. You probably couldn't see it. In fact, it happened so quickly I couldn't see it. But on this screen here, it changed from tap to connect to peer found to connecting, and then ultimately, once this event fired with trigger connection state equal to completed, that tells me I actually have a connection. It's at that point, it's actually at this point, peer found, you can pull the devices apart. It's at this point when you have a socket connection, you can start communicating. So that's all the code that was required to establish a connection. Everything else in this app is just sockets level networking code. So that when the user puts a finger on that screen and draws something, I take all the XY coordinate pairs defining that stroke, package them up in a message, and shoot them out over Bluetooth or Wi-Fi through that open socket over to the other device. On that other end, I simply receive it and I replicate the line that the user drew there. So it's a pretty basically simple stuff. Now, again, Microsoft does not document this. They don't say much about it in public, but they did design this API so that you can connect to Android devices as well. If you know the Android app ID that you can get from that app or from its manifest, then you can connect to non-Windows devices using this as well. I can't demo that because I cannot bear to carry an Android phone. One of these days, maybe I will, but it does work, trust me. So, do you like that? It just gets better and better, doesn't it? Now, think about this. If you're building apps, whether it's a game or something that represents content, music, books, or something like that, think about how you could use this in your apps. So, I did some work last year, quite a lot of work actually, with a company in the U.S. named Nook Media. They build the Nook readers, and once Microsoft acquired part of them, They spent quite a bit of time after building a pretty nice Windows Store app. It was much nicer in version 2 than in version 1. And I was working with them, helping them get over some perf problems and stuff. And I said, you know what? I said, so users can build lists of books on your Nook reader, right? And they said, yeah. And I said, wouldn't it be nice if you could just tap it to another Nook? Or tap it to another tablet running the Nook reader software and share that favorite list of books? If your application deals with content, think about using NFC to share the content. You can share contacts, you can share photos, you can share favorites, you can share bookmarks, or what have you. That, to me, is one of the primary use cases for NFC, especially among developers like us, who are just trying to build and sell apps. Now, we've only got I guess about 4 minutes left, but that's good. I do want to mention one last thing with regard to these NFC APIs here, just real quickly. There is a method in the proximity device class named publish binary message. Now, it's kind of interesting. This is not just for publishing messages with binary data. It is a more generic way to publish a message to any NFC device, whether that device is running the Windows operating system or not. Now, you remember the first demo that I did, where I transmitted a grid of cells from one device to another. I used a method called publish message, and I said, this one is primarily intended for Windows to Windows devices. Publish binary message can talk to non-Windows devices as well. In fact, one of the things it can do, it can actually write to NFC chips. Now, we only have a few minutes left, so I won't demo this, but I carry in my laptop case business cards. And I've put NFC chips on the business cards. You can buy them from places like Amazon.com for $1 or so a piece. With a Windows phone, I can write a little app that's about 10 lines long, and I can write data into that chip that stays there. By the way, one of the reasons NFC requires devices to be close together, when I have, say, two phones communicating, these are both powered devices. They both have batteries. But once I write from my Windows phone a message to an NFC chip, to the sticker I put it back in my business card, there's no battery in that business card. But they use inductive power. When this device is within an inch or so of that unpowered, that passively powered NFC chip, it has two little antennae that draw power inductively from this device, just enough power for me to read the data off of that chip. So you can buy these NFC chips and little stickers. You can stick them on the back of books in your home, books on the back of business cards and things like that. And one of the things this method allows you to do is write data to those NFC tags. So here's a little piece of code that you may find interesting. It's how you specifically write a message containing a URL to the NFC tag. Notice I first used WinRT's data writer to format the data, and ultimately I call publish binary message right here. I have to specify that this is the Windows URI :write tag. That's what tells WinRT that we're actually writing a message out to be stored on an NFC chip, and specifically that it is a URL. Here's the cool thing about this. Once I do that, if I hold any Windows phone or any Android phone up to that business card containing the chip I've written that out on, it will automatically read the URL off and open the browser on that device and take me to that URL. Again, I would demo it, except for the fact that we're just about out of time. So, I hope this is giving you some ideas. If you go away with nothing else, I want you to know WinRT, which today runs on Windows and Windows Phone, has a very nice NFC API built in. Part of that API is the proximity device class, which gives us simple methods for sending and receiving NFC messages directly via NFC while the devices are in contact. Furthermore, WinRT has a peer finder class that allows me to tap two devices together and establish a Bluetooth, Wi-Fi, or Wi-Fi direct connection that I can then use after the devices are pulled apart to shoot data back and forth. You can also use proximity device published binary message to write data like URLs to NFC tags that you can buy rather cheaply online, fix them to business cards, etc. Hope that gives you some ideas. Remember, this URL right here, you can go at your convenience, and you can download the samples that I showed you, plus some that I did not show you right here. All right, thank you very much. By the way, we have a 3-minute break here. I'm in this room next, so we don't have to worry about getting out quickly and perhaps infringing on the other speaker's time. So if you have questions, feel free to hang around during the break or whatever, or come over to the next session, and I'll make sure to get those answered for you. Great, thanks.